Hello everyone, you're welcome to this lesson. In this video, I'm going to solve this question I have on the screen. The question says, find the resultant of the forces shown. So let's look at how you are going to solve this question. So in this case, you will see that we were not given the angles that the forces make with the various axes, okay, but we were given their position vectors. Okay, so you are going to use this to resolve each of the forces into their components and then use that to find the components of the resultant force and then the magnitude of the resultant force. So let's look at how you are going to do that. So let's start with the first force, which I'll name as what? F1, okay, which is given as the 800 newtons, okay. And then this unit, okay, the unit of the position vectors, okay, is in millimeters. Okay, let's take note of that. Okay, all the units are in millimeters. Okay, so for the first force, which is the 800 newton force, let's name its position vector as R1, okay, and then that will be equal to 800 millimeters in the x axis direction, right? And then plus 600 millimeters, okay, in the y axis direction. Okay, so that will be the position vector for the 800 newtons force. So we're going to find the unit vector of what this position vector. Okay, so let's look at that. So to find the unit vector, we must find the magnitude of this position vector. Okay, so that will be equal to 800 squared, okay, plus 600 squared. Okay, this is what you are going to have. So let's simplify this and see what you are going to get. So we have the square root of 800 squared plus 600 squared. Okay, that gives us a value of what? 1000 as the magnitude of what? That position vector. Okay, so let's find the unit vector, which I name as u1. Okay, that will be equal to the position vector. Okay, this is 800 in the x-axis direction plus 600 in the y-axis direction. Okay, all divided by the magnitude, which is what? 1000. Okay, so if we simplify this, you're going to have 800 divided by 1000. That will give us a value of what? 0.8, sorry, 0.8 I, okay, plus 0.6 J. So that will be the unit vector for the 800 newtons force. Okay, so one thing you have to know is that if you multiply the magnitude of the force, which is the 800 newtons, by this unit vector, you are going to get the component of what? That force. Okay, so let's look at it. So you are going to have the first force, okay, which is the F1, okay, resolved into its component as 800 multiplying 0.8 I plus 0.6 J. Okay, that's what you are going to have. So let's simplify this and see what you're going to get for the components of what? The 800 newtons force. So that will be 800 multiplying 0.8, which will give us a value of 640, okay, then plus 800 multiplying 0.6, which will give us a value of what? 480. So that means that the x component of the 800 newton force is 640 newtons, okay, and then the y component is what? 480 newtons. Okay, so you're going to do same for the 400 newtons force. Okay, so let's look at how you're going to do that also. So let's find its position vector. Okay, so for the 400 newtons force, okay, its position vector, okay, will be 480 I, okay, minus 900 J. Okay, that will be the position vector. So let's find the magnitude of this position vector. So that will be equal to the square root of 480 squared, okay, plus 900 squared. Okay, so let's simplify this and see what we are going to get. So the square root of 480 squared plus 900 squared will give us a value of 1020. Okay, will give us this value here, 1020. Okay, so let's find the unit vector. So that will be equal to 480 I minus 900 J. Okay, all divided by 1020. Okay, so let's simplify this and see what you're going to get. So 480 divided by 1020 will give us a value of 0.47, okay, in the x-axis direction, and then minus 900 divided by 1020, which would be minus 0.88 in the y-axis direction. Okay, so let's find the component of the force. Okay, we have F2 to be equal to the 400 newtons, okay, multiplying 0.47I minus 0.88 J. Okay, so let's get our values. So we are going to have 400 multiplying 0.47. That will give us a value of 188, okay, newtons in the x-axis direction, okay, minus 400 multiplying minus 0.88. That will give us a value of minus 352, okay, in the y-axis direction. Okay, so let's write that here. For F2 also we have 188 in the x-axis direction and then minus 352 in the y-axis direction. Okay, so let's do the same for the 424 newtons force. Let's find its position vector. Okay, let's look at that. So for that force also, for its position vector, you're going to have minus 560 in the x-axis, okay, and then minus 900 in the y-axis. Okay, so let's find the magnitude of that position vector. So that will be the square root of 560 squared, okay, plus 900 squared. Okay, so let's see what you're going to get. So we have the square root of 560 squared plus 900 squared. Okay, that gives us a value of 1060. Okay, so let's find the unit vector. So that will be equal to minus 560I minus 900J, okay, divided by 1060. Okay, so let's see what you are going to get for that. Minus 560 divided by 1060, that gives us a value of minus 0.53I. Okay, and then you're going to have minus 900 divided by 1060. That also gives us a value of 0.85. So let's find the component of the 424 Newton force. Okay, so that would be equal to 424, okay, multiplying the unit vector, which is minus 0.53I minus 0.85J. Okay, so let's simplify this and see what you are going to do. So you have 424 multiplying minus 0.53, that will be equal to minus 224.72 I, okay, minus 424 multiplying minus 0.85, it will be minus 360.4 J. Okay, so let's write that also down. So for F3, okay, we have the component as minus 224.72I minus 360.4J. Okay, so we are going to add all these components wise. Okay, so let's add all the x components to get the x components for the resultant force. So we're going to have Rx to be equal to 640 plus 188, okay, minus 224.72. So let's see what you're going to get. 640 plus 188 minus 224.72. That'll give us a value of 603.28 Newton, okay, for the x component. Okay, let's do same for the y component. So for the y component, we're going to have 480 minus 352 minus 360.4. So let's simplify this and see. We have 480 minus 352 minus 360.4. That will give us a value of minus 232.4 newtons. Okay, so that's what you have. So let's find the magnitude of what this resultant force since we know its component. So I'm going to have the magnitude, okay, to be equal to the square root of 603.28 squared, okay, plus 232.4 squared. Okay, so let's simplify this and see what you are going to get. So we have square root of 603.28 squared plus 232.4 squared. Okay, this will give us a value of 646.5 newtons as the magnitude of what the resultant